We've all heard it, right? Fruit is nature's perfect snack. It's vibrant, seems totally guilt-free. Toss them in a smoothie, grab a banana on the way out, snack on mango, because hey, it's fruit. It's healthy. But what if that whole healthy halo around the sweet stuff, around those sweet fruits, is maybe hiding a surprising truth, one that's not so sweet? Today we're doing a deep dive into some really fascinating insights that come from a recent article by Dr. Adanjit Akpombor on Dashing Health. It's titled, The Hidden Risks of Sweet Fruits, What You Need to Know. And I think it's really going to challenge some assumptions we all have about our beloved fruit bowl. It should give you some powerful knowledge.
Yeah, what's really compelling, I think, is how subtly things have shifted. Modern agriculture, well, it's reshaped our food environment without us really noticing. The fruits you find in the supermarket today, they're often way sweeter, sometimes significantly bitter, and just much more packed with sugar than what our bodies, evolved to handle over thousands of years. So this deep dive, it's going to shed light on why that difference isn't just like a small detail. Yeah. It matters profoundly for your health. We're talking impacts from your liver all the way to your brain clarity.
Okay, all right, let's unpack this and the surprising truth about sweet fruit. Let's find out what you need to know to stay sharp, balanced, and keep your energy up. So when we talk sugar, it often feels like this one big bad category. We hear glucose, sucrose, lots of O's. But this article really focuses on a key difference. It says not all sugars act the same in your body, and it singles out one in particular. The author calls it the stealth operator of sugars. Fructose. What makes fructose so different? Why the stealthy label?
That's a really crucial distinction. See, unlike glucose, which pretty much every cell in your body can grab and use for quick energy, fructose, it's mainly handled by just one organ, your liver. And here's where the, let's call it, metabolic trickery comes in. Fructose mostly bypasses the immediate insulin response. So yeah, you don't get that instant blood sugar spike you might expect. But behind the scenes, your liver is working overtime. It gets triggered into this process called de novo lipogenesis.
Okay, de novo lipogenesis. That sounds technical. Break that down for us a bit.
Sure. Yeah, it basically means your liver isn't just like storing fat that you ate. It's literally building new fat molecules from scratch, using that incoming fructose as the raw material. And once the liver kind of fills up its own fat stores, well, that newly made fat has to go somewhere. So it spills over into your bloodstream. It spills over as triglycerides. And those are specific fats that, when the levels get too high, are a major red flag for heart disease risk.
Right, and the article paints this really vivid picture. It says, after a high fructose meal, your blood triglyceride levels can shoot up so dramatically your blood might look like strawberry milk. I mean, that sounds pretty alarming. But what does that actually mean for health long term? Is it just a blip or something more serious?
It means that huge surge of triglycerides isn't just, a temporary thing. It puts immense strain on your entire cardiovascular system. It contributes to insulin resistance, fuels inflammation throughout the body, and significantly bumps up your risk for chronic stuff like heart disease and type 2 diabetes. There was a study published in the journal Obesity that really hammered this home. They compared high-calorie diets. One group got extra calories from fructose, the other from glucose, the fructose group. They had a staggering 113% increase in liver fat.
Wow, 113%.
Yeah, compared to just 59% in the glucose group. That's nearly double the fat creation in the liver. It just highlights how fructose can essentially reprogram your metabolism towards fat storage, even if you aren't necessarily overeating calories overall.
That's a really crucial point, and one I think gets missed a lot. You see labels like, now made with real sugar, or maybe organic cane syrup, and you automatically think, oh, that's better, right? But if even these natural sugars are causing problems, how do we even begin to tell what's actually okay?
It is a super common misconception. Doesn't matter if the label says real, organic, or non-GMO. Standard table sugar, high fructose corn syrup, they're both roughly 50% glucose and 50% fructose. And the article puts it bluntly, natural doesn't mean harmless when it comes to sugar. It's that metabolic trickery again, that lack of an immediate big blood sugar spike. It can kind of lull you into thinking it's fine. But the long-term hit is liver stress, chronic inflammation, and eventually this metabolic breakdown where your cells just don't respond well to insulin anymore. They struggle to get glucose from your blood.
Okay, so most of us connect sugar with, maybe weight gain or energy crashes.
Right.
But the article makes this really striking claim about fructose and the brain.
Yeah.
What did you find most surprising there? What gets deep into your head literally actually mean in this context?
Yeah, it means fructose isn't just messing with your metabolism down in your liver. It seems to have a pretty profound impact upstairs on your cognitive function. One of the most, frankly, astonishing findings came from a UCLA study. It was really compelling work. They gave rats a daily dose of fructose. The amount was equivalent to a person drinking about a liter of soda a day, so quite a bit. And after just 6 weeks, the results were, well, staggering. Of course, they saw the expected things: soaring blood sugar, insulin levels, triglycerides. But the truly shocking part was the noticeable cognitive decline they observed in these rats.
Cognitive decline. How did they measure that? You mentioned a maze earlier.
Exactly. They used maze tests, the fructose-fed rats. They took twice as long to find their way out compared to rats just drinking water. They really struggled significantly more with memory, with learning the maze layout. It showed something was really off.
Okay, so struggling in a maze, that clearly shows a problem. But what's actually happening inside the brain to cause that?
Well, this is where it gets even more profound, kind of the genetic level aftermath. The researchers dug deeper and discovered something incredible. Over 1,000 brain genes were altered in that fructose-fed group.
1,000 genes changed by sugar.
Yes, over 1,000. And these weren't just, random background genes. They were genes specifically linked to serious neurological and mental health conditions. Things like Parkinson's disease, depression, bipolar disorder, general cognitive dysfunction, and neuroinflammation. It was a huge range. The lead researcher, Dr. Fernando Gomez-Pinilla, summed it up perfectly. He said, "Food is like a pharmaceutical compound. It really drives home that your diet isn't just fuel. It's sending powerful signals capable of literally rewriting your brain's blueprint, for better or for worse."
Wow, that's incredibly sobering. So hearing that, the immediate question is the damage done? Can anything counteract this? Is there any hope for our brains if we've had too much fructose?
Thankfully, yes, there is hope. The UCLA researchers didn't just stop at the bad news. They explored potential antidotes, too. They took some of those fructose-fed rats and supplemented their diet with DHA. That's a key omega-3 fatty acid, the kind you find abundantly in fatty fish like salmon or in good-quality fish oil supplements. And the results were really encouraging. They saw improved brain function in those rats. They saw a partial reversal of that disruptive gene activity they documented. And crucially, those DHA-supplemented rats performed better in the maze tests again. It just powerfully shows the brain's amazing plasticity, its ability to respond to what we feed it. It proves that dietary choices can either harm or they can actively help heal your brain.
This metabolic disruption, especially in the liver, it sounds like the kind of thing that could snowball into bigger health issues, right? What does the article say about conditions like non-alcoholic fatty liver disease?
Yeah.
NAFLD calls it a full-blown public health crisis.
Yeah.
That sounds serious.
It is an alarming picture, yeah. NAFLD currently affects something like 70 million adults just in the US. That's about 1 in 3 people. And the projections, if trends continue, it could affect half the US population by 2030.
Half the population. Wow.
It's becoming so widespread that some doctors are even calling it diabetes of the liver. And the core problem, getting back to our main topic, is how fructose fuels this liver fat accumulation. It gets converted directly into fat through that de novo lipogenesis pathway we talked about. Over time, this buildup leads to inflammation, then scarring, and it can progress to really serious liver diseases, NIH, cirrhosis, even liver cancer.
What really struck me, though, was the point that even people at a healthy weight are at risk. Like 10–15% of thin people apparently have NAFLD. That completely challenges the idea that if you look skinny on the outside, everything must be fine on the inside. Why doesn't weight protect you here?
It really does challenge that assumption. It shows that sugar metabolism, especially from processed foods and sugary drinks, doesn't care what the scale says or how you look externally. You can absolutely be thin, but still have an inflamed fatty liver working overtime. And if the liver is taking such a hit, what about the brain connection? We often think of liver issues as separate, just affecting the liver. But research is showing this surprising link. Studies actually indicate that cognitive deficits, things like brain fog and memory issues, they increase as NAFLD gets worse.
So wait, the fattier the liver, the foggier the mind. Is that what you're saying?
Essentially, yes. The fattier the liver, the foggier the mind. The connection is likely complex, involving systemic inflammation spreading from the liver throughout the body. Also, metabolic disruptions and maybe even toxins generated by the unhealthy liver that manage to cross the blood-brain barrier and directly impact brain function. So, if you're consistently experiencing brain fog or memory lapses, it's not always just stress or aging. Your liver might actually be sending out a distress signal.
Okay, this is fascinating, but also a bit concerning. We often think of sugar as a quick, feel-good treat, right? A pick-me-up when you're down. But the article flips that script. It reveals this deep, kind of disturbing link between fructose and mood, potentially even leading to clinical depression. How on earth does that work?
It seems to start right in your gut. When you consume fructose in large amounts, especially from, say, sweetened drinks or highly processed foods where it's concentrated, your gut actually struggles to absorb it all efficiently. So excess fructose ends up just lingering in your intestines. There, it starts to ferment. And it tends to feed the wrong kinds of gut bacteria, leading to those classic IBS-like symptoms a lot of people experience. Gas, bloating, cramps, sometimes diarrhea.
Okay, so digestive upset, that makes sense. But the article mentioned something more specific, too, about tryptophan interference. What's that about?
Exactly. It gets more intricate. High levels of unabsorbed fructose hanging around in your gut can actually block the absorption of a really important amino acid called tryptophan. And this is a very big deal because tryptophan is the direct building block your body needs to make serotonin.
Ah, serotonin, the feel-good neurotransmitter.
Precisely. Serotonin is absolutely vital for regulating mood, emotional balance, sleep cycles, even memory and focus. So, put simply, if excess fructose in your gut is preventing tryptophan from getting absorbed properly, your brain might literally be starved of the raw material it needs to produce enough serotonin. And that directly impacts your mood, making you more vulnerable to symptoms of anxiety and depression.
Wow. Okay. And then the article takes it another step, talking about how concentrated fructose can weaken the gut lining itself, leading to leaky gut. This allows things like bacterial bits and inflammatory compounds to actually get into your bloodstream. How does that connect back to mood?
Right, so now you've got these inflammatory molecules circulating throughout your body. They don't just stay local, they activate your immune system everywhere, including, crucially, in the brain. This immune response can lead to inflammation within the brain tissue itself. It can trigger the release of stress chemicals and disrupt that delicate balance of neurotransmitters we need for stable mood. Ultimately, all this can contribute significantly to depression, anxiety, and that general feeling of brain fog. Researchers are increasingly calling this specific mechanism inflammatory depression, and the thinking is it might be far more common than we currently realize, often driven by diet and gut health.
Okay, this is a lot to take in about fructose. It really raises a critical question, the one I bet many listeners are thinking right now. Does this mean all fruit is bad? Should we just avoid fruit entirely based on everything we've discussed?
No, absolutely not. And the article is very clear on this distinction. It states explicitly, fructose in isolation is the villain, but fructose in whole fruit is not the enemy. That's a key takeaway. Think about processed fructose, like what's in fruit juice or soda. It's been stripped bare of all its natural fiber. It's highly concentrated, and it hits your system incredibly fast, overwhelming your liver and gut.
Right, like drinking orange juice versus eating an orange. Huge difference.
Exactly. Whole fruit delivers its fructose package perfectly with essential fiber, lots of water, vitamins, minerals, and those beneficial plant compounds called phytonutrients. That whole package dramatically slows down how quickly the sugar gets absorbed. It lessens the blood sugar impact. It's easier on your gut, easier on your liver. And think about volume, too. You could easily gulp down the sugar equivalent of, say, 5 apples in a single large glass of apple juice in minutes. But trying to sit down and actually eat 5 whole apples back to back, that's incredibly difficult, right? Your body's natural fullness cues would kick in hard.
Yeah, no kidding. I'd be stuffed after maybe 2.
Right, that built-in portion control is vital. Whole fruit is naturally self-limiting in a way that processed sugar, which is often engineered to bypass satiety and make you want more, just isn't.
Okay, that makes sense. But for years, the common advice was always, fruit is nature's candy. Eat as much as you want. It sounds healthy. But the article brings up a really important point. The fruit we eat today isn't quite the same as what our, say, hunter-gatherer ancestors ate. How has that relationship changed, and why does it matter?
It's a massive difference, really. The fruit our ancestors might have found foraging wasn't anything like the super sweet varieties in modern grocery stores. Wild berries were often tart, maybe a bit bitter. Wild apples were small, sometimes quite sour. Fruit was definitely seasonal, often scarce, and probably a real treat when found. Now fast forward to today. We've spent decades, centuries even, selectively breeding fruit for maximum sweetness, for larger size, for longer shelf life. We eat it year-round, completely disconnected from natural seasons, and we consume it frequently in concentrated forms like juices and dried fruit, which just amplifies that sugar load even further. From an evolutionary perspective, our bodies just aren't equipped to handle this constant high-level influx of fructose day in, day out, even if it's technically from a natural source like fruit. And here's where it gets really interesting and maybe a bit controversial, specifically looking at brain health again. Some surprising research, mostly observational studies so far, suggest that too much fruit intake might actually affect brain volume. One large study looked at older adults and found that higher fruit intake was linked to reduced volume in the hippocampus.
The hippocampus.
Yeah.
It's the memory center.
Exactly. Key for memory, emotion, learning, spatial awareness. And another study seemed to echo this concern. It found that higher intake of specifically sugary fruits, think mangoes, pineapples, bananas, was negatively associated with cortical volume. That's the brain's outer layer, responsible for higher level thinking, decision-making, processing information. So, studies challenge that blanket advice to just eat all the fruit you want. They suggest that, at least for optimal brain health, the type of fruit and definitely the quantity really seem to matter.
That is genuinely surprising. More fruit potentially linked to less brain volume in some cases. Okay, so after hearing all this, the big question remains, should we quit fruit altogether? Is that the conclusion?
No, absolutely not the conclusion. But context and quantity are everything. The article stresses this. For individuals who are already dealing with things like diabetes or significant insulin resistance, the sugar load, even from whole fruit, can be problematic. For them, even a single seemingly healthy orange can cause a really sharp, prolonged blood sugar spike that might stay high for hours. In those specific cases, the sugar hit can sometimes outweigh the benefits when insulin signaling is already impaired.
Okay, so maybe restriction is needed for some people, at least temporarily.
Yes, potentially. But the good news is, it's often not a forever thing. The goal isn't usually to ban fruit for life. It's more about resetting your metabolism first, getting your insulin sensitivity back on track through targeted dietary changes, maybe more exercise. Once your body is handling sugar better, many people find they can reintroduce moderate amounts of whole, unprocessed fruits without causing those huge disruptive spikes. And when it comes to choosing fruit, especially if you were watching your sugar intake, there are definitely some low sugar superstars. Think things like avocado, olives, yes, they're botanically fruits. Also coconut and raw cacao, the base for dark chocolate. And then, probably most importantly, berries, all kinds of berries. They are naturally low in fructose, but incredibly high in beneficial compounds like polyphenols, which are fantastic for brain health and fighting inflammation. The article even gives a nod to dark chocolate, saying that enjoying dark chocolate with at least 70% cocoa content, in moderation of course, can actually be genuinely brain healthy thanks to those cacao flavonols.
Right, and those very impressive brain benefits you mentioned earlier really stand out. That Nurses' Health study finding. Women eating the most berries, having brains that look 2.5 years younger on scans, plus slowed cognitive decline, better memory. That's pretty compelling evidence for berries.
It really is compelling stuff. Maybe to wrap up with some practical takeaways, some smart fruit strategies based on the article. Stick mainly to lower sugar fruits. That means berries are your best friends, but also things like green apples, kiwi, maybe some citrus. Always try to eat your fruit with some protein or healthy fat. This dramatically slows down sugar absorption. So instead of just an apple, have it with a handful of almonds or maybe some Greek yogurt or a piece of cheese. Simple trick, a big difference.
Good tip. Avoid the naked fruit snack.
Exactly. And definitely avoid fruit juices. There's basically just liquid sugar without the fiber. Be really mindful of dried fruit too. It's super concentrated sugar in a very small, easy to overeat package. And maybe most importantly, just track how you feel. Pay attention. Treat fruit like a food, a nutrient source, not like a free pass that's somehow exempt from the metabolic effects of sugar just because it grew on a tree. It's healthy in moderation, yes, but it's not magic.
Okay, so bringing this all together, what does it mean for you listening? I think the big takeaway from this deep dive is pretty clear. Fruit itself isn't the enemy here. But unchecked fructose, especially the kind concentrated in processed foods and drinks, definitely warrants caution. It's really about being informed, being aware, and making smarter choices.
Yeah, and maybe it raises a more personal question for everyone listening. In this world where natural on a label doesn't always equate to harmless for your metabolism, how will you maybe adjust your thinking? How will you make smarter choices about the sweet things in your diet moving forward? Perhaps it's time to, reframe that relationship with the fruit bowl a little bit.
We've definitely covered a lot of ground today, from the liver to the brain, the gut, your mood, all these complex ways fructose impacts your health. If you want to go even deeper and read the full original article by Dr. Aydan Cestet Okbambor, that inspired this discussion. You can find the link right below this video. We highly recommend checking it out. And hey, if you found this deep dive valuable, if it gave you some food for thought, please do us a favor, hit that like button below, and make sure you subscribe to the Dashing Health channel. We'll keep bringing you more insights like this to help you be sharp, maybe a little less sweet, but definitely smarter about your health. Thanks for joining us.